So I will try and cover a few aspects of us and our relationship to the universe. It doesn't matter how many slides are covered, but what is important is that you learn to question. So what the picture we see over there, it is your picture. So that is a picture of our Milky Way, the galaxy in which you reside, যেটো তৰ্কাৰাজ্যত আমি থাকো। সেই ছবিখন চালে what you can see are lot of dark patches of light. আমি সদায় সৰুৰে পৰা শিকি আহোঁ যে আমাৰ তৰ্কাৰাজ্যত millions and billions of stars, বহুত তৰা আছে। কিন্তু what are all these regions? এই ডাৰ্ক পেচবিলাক কিহৰ? ৰাতি আমি যেতিয়া ওপৰলৈ চাওঁ আকাশখন আমি তৰা দেখোঁ। আমি যদি if you take a fixed volume of space আৰু আমি সোধো যে তৰাবিলাকে কিমান ভলিউম অকুপাই কৰে, what is the percentage of volume of space that is occupied by the stars? You will find that that number is extremely small. তেতিয়াহ'লে সেই তৰাবিলাকৰ মাজত if the stars occupy so little volume of space, then the next question to ask oneself is the তৰাবিলাকৰ মাজত কি আছে? So when you ask yourself questions, প্ৰথমতে মানুহে ভাবিছিলে যে তৰাবিলাকে আছে। কিন্তু slowly we realized towards the beginning of the last century that the space between stars is not empty. And that is the region where new stars, নতুন star জন্ম হয়। আৰু যিবিলাক এতিয়া আন্ধাৰ দেখা হৈছে, the dark patches which you see are regions where there are a lot of dense clouds of gas between the stars. If there are a lot of clouds of gas and dust, then you will not see the stars behind. So what you see over there as the dark patches are regions of dense gas and stars. And these dense gas of stars which you see are very intimately related to us. কারণ আমার যেনেকৈ আমি জন্ম হওঁ, আমাৰ মৃত্যু হয়, similarly সূৰ্য বা তৰাবিলাকৰো জন্ম হয়, তৰাবিলাকৰো মৃত্যু হয়। And these dark patches বোৰ দেখিছে, those are the dense regions, that density বেছি। আমাৰ এটমস্ফিয়াৰতকৈ ডেন্সিটিটো বহুত কম, কিন্তু যদি আমি তৰাৰ মাজৰ জেগাখিনি চাওঁ, the density is extremely high over there. And those are the regions where new stars are formed. And this formation and the death of new stars is intimately related to the existence of you, me, everybody else, and the earth itself. Amar Khori to our body, what do you think by mass are the elements which make us up? Elements of the periodic table. Carbon is one. Some more. Carbon is not the maximum, but carbon is definitely on the upper part. Very good. Sorry. Hydrogen is very good. Oxygen is very good. Excellent. Okay. Now, hydrogen is abundant, is the most abundant element in the universe, but because it has just one proton and one electron, by mass it does not make up a significant fraction. Oxygen is the heaviest. Oxygen, carbon, nitrogen, hydrogen, nitrogen. So some of these major elements make up a large fraction by mass of our bodies. All right? And there are lots of trace elements as well. Potassium, sodium. Doctors will tell you, as we go old, if there's even a slight imbalance of these vital elements, they're small in fraction, but they're extremely vital for the whole metabolism of our body. The universe originated in a very hot phase when everything was ionized and hydrogen first formed with protons combining with electrons. And that is the most abundant element. Where did this oxygen come from? Where did carbon come from? From the stars. Because the only way that we know it can only happen through the process of nucleosynthesis in the interiors of stars. Amar Khurjar Bhitorato, the way the energy is generated by combining protons to form helium, protons combine to form helium and release nuclear energy. Into Amar Torato, the sun is a relatively modest sized star. যদি আমি oxygen, carbon, আমি সৃষ্টি কৰিব যাওঁ, তেতিয়াহ'লে we need more massive stars, কাৰণ তৰাটো যিমানে ডাঙৰ হয়, তেতিয়া তাৰ তাপমানটো ভিতৰত বেছি হয়. So if the stars are more massive and the temperature is higher, then you can fuse together heavier sort of charged particles or to form higher and higher elements. Amar সূৰ্য তৰাই কেতিয়াও কাৰ্বন বা অক্সিজেন কৰিবলৈ দিগদাৰ অসুবিধা হ'ব. But the thing is that যদি সৃষ্টি হ'লে within a heavy star, then how does it become part of our life? Help to create life? How did it help to actually first form the first signs of the first unicellular organism? That carbon is synthesized in the interior of stars, it has to get out, isn't it? তৰাৰ ভিতৰতে থাকিলেতো নহ'ব, তৰাৰ পৰা বাহিৰত ওলাব লাগিব যদি আমাক if we are made up of carbon, oxygen, etc. So that happens because the stars which are born, তৰা যেনেকৈ জন্ম হয়, তৰাৰ মৃত্যু হয়। আমাৰ তৰাটো সূৰ্যৰ মৃত্যু কেনেকৈ হ'ব? It will die a quiet death. Small mass stars die a quiet death. It will shed some of its outer material আৰু হ'ব সৰু এটা তৰা white dwarf বুলি কয়। কিন্তু if there is a more massive star, তাৰ শেষত মৃত্যু কেনেকৈ হয়? It ends in a massive explosion. Massive explosion leaves behind a star called a neutron star or a black hole, depending on the mass of the star. তৰাটোৰ মাছ কিমান গধুৰ সেইটোৰ ওপৰত নিৰ্ভৰ কৰিব। কিন্তু once that explosion takes place, all these elements are thrown out into interstellar space. And from these interstellar space are these clouds of gas, which you see over here, are the dark patches from which the next generation of stars and the planetary systems form, just like the sun and the earth and our planetary system. So the existence of stars and the evolution of stars, their birth and their death, তেওঁলোকৰ তৰাৰ জন্ম আৰু মৃত্যু, সেইটো আমাৰ কাৰণে অতি প্ৰয়োজনীয়, কাৰণ সেইটো নোহোৱাহেঁতেন আমি আজি মই নাথাকিলোহেঁতেন বক্তৃতা দিবলৈ, ISS নাথাকিলেহেঁতেন science organize কৰিবৰ কাৰণে. So it is important, and this journey has been a long one. I've said something in very, very sort of few words into the whole journey of understanding how nuclear reactions take place and how the energy is synthesized in the interiors of stars. It's a long story where hundreds of scientists have contributed over literally decades, more than a century now. কিন্তু আমি বিজ্ঞানত যদি কিবা এটা কওঁ যে এইটো হৈছে, তাৰ প্ৰমাণ এটাও লাগিবতো সদায়, নহয় জানো? If I say today that nuclear reactions is the way that energy is generated in the interior of the sun, তাৰ প্ৰমাণ, and the answer is as follows: that today, if I look at nuclear reactions taking place in the interior of the sun, I can only see the outer sphere of the sun, that tapman about 6000 degrees Kelvin. It has a black body spectrum, আৰু সেইকাৰণে আমি সূৰ্যটো দেখা পাওঁ, কিন্তু ভিতৰতটো আমি দেখা নাপাওঁ. We can't see the interior of the sun. So how do we know that what we are assuming is correct? So one of the essential things is that nuclear reactions, যিটো proton combine কৰি পেলাই heavier elements synthesize হয় আমাৰ সূৰ্যৰ মাজত, the process gives out elementary particles called neutrinos. Neutrinos are very small cross section of interaction. যদি মোৰ থিয়ৰিটো শুদ্ধ হয়, তেতিয়াহ'লে মই সেই নিউট্ৰিনোটো ডিটেক্ট কৰিব পাৰিব লাগিব, আৰু তাৰ সংখ্যাটো শুদ্ধ হ'ব লাগিব, কাৰণ মই জানো যে কিমান নিউক্লিয়াৰ ৰিয়েকশ্যনছ লাগে, কাৰণ সূৰ্যৰ লুমিনচিটি বা কিমান এনাৰ্জি তাৰ পৰা ওলাইছে. I can calculate that. So I know the physics of these reactions, and I can also predict the exact number of neutrinos which should be emitted. And you'd be surprised by the number of neutrinos that are emitted. কাৰণ মই যদি মোৰ বুঢ়া আঙুলিটো সূৰ্যৰ ফালে দি দিওঁ, the number of neutrinos that are going through the thumb, তোমালোকে যদি কোনোবাই জানা কোৱা, it is not 10 or 20 or 30. It's about 10 to the power of 17 or 18. কিন্তু আমাৰ একো নহয়, কাৰণ interaction cross section is very low. The huge sort of detectors which have been put underground, and the images of the sun which have been made by looking at the sun through the earth to detect a few neutrinos which might interact with thousands of gallons of water and give off a little amount of radiation by interaction. কিন্তু আমি সেই নিউট্ৰিনৰ সংখ্যাটো কিমান হ'ব লাগে আৰু কিমান ডিটেক্ট কৰিব লাগে, it is only after we have been able to ascertain that মানুহে আমি বিশ্বাস কৰোঁ যে what is happening, our theory is probably correct. আমি অন্ধবিশ্বাস কেতিয়াও নকৰোঁ science-ত. A good theory is always one which can predict what you can see and experimentally আমি verify কৰিবলৈ চেষ্টা কৰোঁ. Discovery of the Higgs boson, আৰু যোৱা 2 বছৰ আগতে 1960-17, the discovery of gravitational waves. These are beautiful theories which are predicted, which were worked out, but we always confront them with experiments. কাৰণ আমি experimentally confirm কৰিব পাৰিলেহে আমি theoryটোৰ ওপৰত ক'ব পাৰোঁ যে আমাৰ বিশ্বাস আছে, and then we keep going forward. আমি যেতিয়া ৰাতি চাওঁ তৰাবোৰ, when we look at the stars at night, আমি চকুৰে চাওঁ, নহয় জানো? আমি চকুৰে চাওঁ, আৰু আমি ধৰক দেখিব পাইছোঁ, and that is because of sunlight or light which is reflected and comes to our eyes. Now আমি যদি বিশ্ব ব্ৰহ্মাণ্ডখন study কৰিব খোজো, তেতিয়াহ'লে we cannot be confined just to optical light. আৰু আমাৰ সৌভাগ্য যে one thing is, মই তলৰ পিকচাৰখনত ইয়াত দেখুৱাইছোঁ যে what kind of light is cut off by our atmosphere. আমাৰ এতিয়া কিৰণবোৰ যিটো আমি চকুৰে চাওঁ, এইটো ইলেক্ট্ৰমেগনেটিক ৱেভছ বুলি কয়, oscillations of electric vectors and magnetic fields, magnetic vectors, আৰু সেই সূৰ্যৰ কিৰণটো propagate কৰে. এই লেজাৰ লাইটটো যেনেকৈ propagate কৰে, মই অন কৰি দিছোঁ, কিন্তু সেই তেনেকুৱা ধৰণৰ কিৰণবিলাক ট্ৰানজিষ্টৰটো অন কৰিলে ৰেডিঅ' ৱেভটো যিটো শুনা যায় বা হাতখন ভাঙিলে এক্স-ৰে ল'লে it is exactly the same kind of electromagnetic radiation except that তাৰ ফ্ৰিকুৱেঞ্চিটো বেলেগ বা ৱেভলেংথটো বেলেগ আৰু তাৰ গতি ইলেক্ট্ৰমেগনেটিক ৱেভছৰ আইনষ্টাইনে আমাক শিকাই থৈ গৈছিলে যে 2.9979 into 10 to the power of 10 centimeters per second তাৰ গতি আৰু তাতকৈ কোনো বস্তু তাৰ সেই গতিতকৈ বেছি হ'ব নোৱাৰে না আমি যদি ব্ৰহ্মাণ্ডখন ষ্টাডি কৰোঁ when we study that you will notice that it's only a narrow range of the electromagnetic spectrum which is transparent তাক মানে আমি দেখা পাব পাৰোঁ এইখিনি যদি ব্লক হৈ থাকিলেহেঁতেন তেতিয়াহ'লে we would not have actually seen the sun যদি আমাৰ সূৰ্যটো খুব ডাঙৰ হ'লহেঁতেন then it would have radiated in the ultraviolet region of the spectrum ultraviolet কি হয় wavelengthটো সৰু আৰু frequencyটো ডাঙৰ তেতিয়াহ'লে it would have been cut off by some of these by our atmosphere our atmosphere কিয় cut off কৰে because there are molecules there are water vapor nitrogen carbon monoxide ozone এইবিলাক এতিয়া ozone their report there are a lot of debates about it because if the ultraviolet light came through then it would cause increased skin cancer and all that so it's important to maintain the balance in the atmosphere but as far as studying the universe is concerned you can see that the only rays come through কিন্তু আমি যদি অকল সেইটোৰ ওপৰতে নিৰ্ভৰ কৰোঁ অতীতৰ কালৰ পৰা আমি বিশ্বব্ৰহ্মাণ্ড চাওঁতে চকুৰে চাই আহিছিলোঁ তাৰপিছত টেলিস্কোপ বনালোঁ অপটিকেল টেলিস্কোপ কিন্তু if we only confine ourselves to that part of the electromagnetic spectrum then our view of the universe is rather narrow কিন্তু আজিৰ দিনত we study the universe in all the different wavelengths from the long wavelength radio waves to the highest energy gamma rays so we study the universe in all its constituents and that has really enriched our knowledge of the universe আমাৰ বিশ্বব্ৰহ্মাণ্ডখনৰ বিষয়ে জানিবৰ কাৰণে আমি ৰেডিঅ' ৱেভছৰ পৰা গামা ৰেজলৈকে আমি আজি শিকোঁ because this is transparent over here light comes through but in all other regions except in the radio region of the spectrum you can hear that light is cut off by the atmosphere so কালি যদি মই এক্স-ৰেজত মই মোৰ বিশ্বব্ৰহ্মাণ্ডখন কেনেকৈ চাবলৈ বিচাৰোঁ then you will find that you'll have to put telescopes outside the atmosphere আৰু প্ৰত্যেকটো উইন্ডো যেতিয়া ওপেন আপ হৈ গৈছে we have found new and exciting discoveries of the universe constituents of the universe so the browner this is that means the radiation is completely cut off there's some windows over here or this is also cut off radio window is over here and at long wavelengths the radio is also cut off long wavelength the radio to cut off হয় because we have an ionosphere surrounding us আৰু খুব বেছি long wavelength হ'লে বাহিৰৰ পৰা কিৰণবোৰ the radio waves don't come through and because of the ionosphere earlier radio waves you could get it reflected from long distances you could listen to music from radio Ceylon but as far as radio astronomy is concerned you look at the universe we cannot observe less than about 10 megahertz in frequency which means several meters in wavelength and I also want to point out that this is a coincidence perhaps that আমাৰ সূৰ্যটোৰ যিটো তাপমান surfaceত that temperature also peaks at about 5000 degrees Kelvin আৰু 5000 degrees Kelvinত পিক কৰিলে তেতিয়াহ'লে কি হয় সূৰ্যৰ কিৰণবিলাক এইটো ৰিজিয়নতে maximum intensity আহে so আমাৰ চকুবিলাকে যে our eyes are able to perceive light from the sun which comes through it হয়তো because of the biological evolution of the human life of the human eye the primitive organisms they had just photoreceptor cells so our eye is a very advanced organism and it is actually tuned to observing or tuned to looking at things from light which passes through atmosphere and which also is the part where the emission from the sun peaks কাৰণ সূৰ্যৰ তাপমানটো সৰু হোৱাহেঁতেন আমাৰ সূৰ্যটো if it was less massive it would have emitted in the infrared region of the spectrum that also would have had difficulties getting through if it was much bigger then it would have radiated in the ultraviolet which would have also had difficulty going so it seems to have the right mass to emit the energy in the right range of the electromagnetic spectrum and our atmosphere has also been tuned to let this radiation come through and that is why man since antiquity অতীতৰ কালৰ পৰা চকুৰে প্ৰথমতে চাই আহিছিলে in fact Aryabhatta and earlier Greeks and Islamic sort of astronomers they studied the universe with their naked eyes till the telescope was actually made in the Middle Ages the dark patches we weave a lot of stories about the constellations. We have mythical stories. In the southern hemisphere, for example, where you can see the dark clouds very clearly, there are also communities and societies like the Aborigines of Australia, which actually have stories about the dark patches. So this is an Aboriginal story of a particular Aboriginal tribe, the emu laying eggs. This part of the sky is up in the zenith at that time of the year when the emu lays the egg. Emu is a flightless bird. এইটো অষ্ট্ৰেলিয়াত পায়, চৰাইটো নুৰে, মাটিতে থাকে, আৰু এই চৰাইটোৰ আৰু চৰাইটোৱে যেতিয়া কণী পাৰে সেইটো সময়তে this part of the sky is at the zenith, and these engravings which you see, which have been taken, is tens of thousands of years old. Aboriginal culture and society, সমাজখন অতীতৰ কালৰ, today it has been colonized and it is more European, it's more international now. Amar সমাজৰ মাজতো, আমাৰ জনগোষ্ঠীৰ মাজতো, I'm sure there are a lot of interesting tales about the universe and what we see in the sky. এতিয়া winter constellation, I'm just looking at Orion Star constellation, which you can see in the winter sky. Lunar eclipse সময়ত this was almost up in the sky. It is still visible. আৰু Orionৰ লগত there is a diffuse batch of cloud called the Orion Nebula. That আমি অকল optical region চালে নহব, that we need the entire part of the electromagnetic spectrum to look at the universe in detail. So before I go into that, I'll ask you a question. Okay, studenter কাৰণে অকল যে গধূলি বা ৰাতিপুৱা সূৰ্যটো দেখিলে কিয় ৰঙা দেখা? Why is it red early in the morning and late in the evening? Sorry, basically reflect নকৰে, কি হয় আচলতে নীলা ৰঙৰটো ৱেভলেংথটো কমটো, সেইটো আচলতে আমাৰ বায়ুমণ্ডলত যিবোৰ ডাষ্ট গ্ৰেইন বা মলিকিউলছ থাকে সেইটো স্কেটাৰ কৰি গুচি যায়, কিন্তু যিটো কিৰণৰ ৱেভলেংথটো দীঘল সেইটো অলপ সহজে আহি যায়, ৰাইট, অলপ সহজে আহি যায়। সেইকাৰণে দেখিবা যে যেতিয়া আমি লং ৱেভলেংথত বিশ্ব ব্ৰহ্মাণ্ডখনো চাওঁ, তেতিয়া আমি দীঘলীয়া ৱেভলেংথত কিৰণত চালে তেতিয়া আমি বেছি দলৈকে চাব পাৰোঁ। আৰু যেতিয়া প্ৰথমতে মই ছবিখন দেখুৱাইছিলোঁ যে ডাৰ্ক ক্লাউডছবোৰ দেখে, কাৰণ অপটিকেলত কি হয়, সেই লাইটবোৰ যিবোৰ এবজৰ্বড হৈ যায় বা স্কেটাৰ্ড হৈ যায় তেতিয়াহ'লে ক'লা যেন দেখে, কিন্তু মই যদি সেইখিনি জেগাকে ইনফ্ৰাৰেডত চাওঁ য'ত কিৰণৰ ৱেভলেংথটো দীঘল, তেতিয়া যেনেকৈ ৰঙাৰ ৱেভলেংথটো দীঘল নীলাতকৈ আৰু ৰঙাৰ ৱেভলেংথটো আহে, তেতিয়া আমি দীঘলীয়া ৱেভলেংথত চালে you'll find that more of the radiation is able to come. If you want to probe a little deeper, we'll have to look at different wavelengths as well. This is a region of star formation in the universe called the Orion Nebula. It is ভাল binoculars হলে আৰু city lightবোৰ নাথাকিলে দেখা পোৱা যায়. It is in the belt, it is below the belt of Orion, the constellation. আৰু ইয়াত দেখুওৱা হৈছে যে a couple of pictures, ইয়াত optical দেখুওৱা হৈছে আৰু ইয়াত infrared দেখুওৱা হৈছে. And what you notice over here is that you see a lot more of the diffuse emission in the infrared compared to the optical. All right? Compared to the optical. মই খুব complicated কৰিব নাযাওঁ, কিন্তু আৰু কেতিয়াবা কি হয়, আৰু ইয়াত নীলা যিটো দেখা গৈছে, কি হয় আমাৰ তৰাবিলাকে they can also heat up gas to very high temperature. খুব তাপমানটো বেছি হ'লে আমাৰ যেনেকৈ সূৰ্যৰ তাপমান যদি 6000 degrees Kelvin হয়, and we see it in the optical region of the spectrum, যদি we have gas which is heated to say million degrees Kelvin, খুব বেছি তাপমান বেছি হ'লে, then what it will do is it will emit in the X-ray region of the spectrum. এতিয়ালৈকে মই কি কৈ আহিছিলোঁ, I've talked about temperatures which are very large, কিন্তু এই যদি টেম্পাৰেচাৰটো খুব বেছি হয় তেতিয়াহ'লে it is very difficult for clouds to collapse. All the dark clouds which are talked about are clouds which are cold and which are dense. যদি তাপমানটো খুব কম, তেতিয়া you'll find that these clouds are also rich in their chemistry. So they have all kinds of molecules over there. আৰু সেই moleculesবোৰ চাবৰ কাৰণেও কি হয়, এতিয়া মই যদি হাইড্ৰজেন চাব খুজিছোঁ, it transits from one energy level to another, আমি এটা লাইন ডিটেক্ট কৰিব পাৰোঁ। আৰু হাইড্ৰজেনৰ লাইনবিলাক we can see it in the ultraviolet, we'll see it in the optical, okay, we'll see it in the infrared also. কিন্তু কেতিয়াবা কি হয়, if it is very cold, তেতিয়াহ'লে we can only detect the molecules যিবোৰ molecular transitions হয়. All right? So this is an image of the Orionৰ মই যিটো constellation দেখুৱাইছিলোঁ আগতে, এই যিবোৰ ৰঙাৰ দাগ লাগি আছে, so that is carbon monoxide in emission. কাৰণ আমাৰ বিশ্ব ব্ৰহ্মাণ্ডত যিবোৰ ক'লা dark clouds আছে, they are not only dense and dark, they consist of dust, consists of gas, but this also consists of all kinds of interesting molecules: formaldehyde, water vapor, carbon monoxide, hydrogen molecule, cyanodecapentide. And a molecule will form although we haven't detected DNA or more advanced molecules, but these are the basic ingredients which actually make up, hopefully at some stage, life itself. So this is just an illustration of the hydrogen transition which I talked about. Yeah, at a level of a two level electron to gole, then you'll find that it emits in the red region of the spectrum. এতিয়ালৈকে যিখিনি কৈছিলোঁ কিবা বুজা নাই বা প্ৰশ্ন আছে নেকি? I'll just take a 1 minute break. আচলতে আমাৰ বিশ্ব ব্ৰহ্মাণ্ডখন অতীতৰ কালৰ পৰা আমি প্ৰশ্ন সুধি আছো যে তাৰ কেনেকৈ জন্ম হ'ল আৰু গতিটো কিয় আছে। 1920s মানত এডুইন হাবল নামৰ এজন এষ্ট্ৰনমাৰে তেখেতে আৱিষ্কাৰ কৰিছিল যে আমাৰ তৰকামণ্ডল আমাৰ নিচিনা বহুত বেলেগ তৰকামণ্ডল গেলেক্সিজ বা তৰকামণ্ডলৰ ৰাজ্য আছে আৰু প্ৰত্যেকটো তৰকাৰাজ্য এটাৰ পৰা ইটোৰ পৰা আঁতৰি গৈ আছে। যিটো গতিৰে আগবাঢ়ি গৈ আছে, the velocity at which it is moving ahead is proportional to the distance. এতিয়া বেলুন এটা লৈ পেলাই যদি আমি ফুলাই থাকোঁ, প্ৰত্যেকটো পইণ্টৰ পৰা ইটো পইণ্ট আঁতৰি গৈ থাকিব, নহয় জানো? চ' দেট ৱাজ দ্য পিকচাৰ। সেইটো ছবি আছিলে অলপ আজি 10-15 বছৰ আগলৈকে। নাও উই ন', এতিয়া আমি জানো যে ইউনিভাৰ্ছখন অকল ইউনিফৰ্মলি আগবাঢ়ি থকা নাই, বাট ইট ইজ অলছ' এক্সেলাৰেটিং। আজি বিশ্ব ব্ৰহ্মাণ্ডত যিবোৰ বেৰিয়নিক মেটাৰ বুলি কয়, যিটো হয়তো তুমি মই বা যিকোনো আমি পৃথিৱীখন সূৰ্য গোটেইখিনি আমি যিটো চকুৰে বা দূৰবীণেৰে দেখা পাওঁ, যিটো আমি বেৰিয়নিক মেটাৰ বুলি কওঁ, প্ৰটন, নিউট্ৰন, ইলেক্ট্ৰন, যিটো সেইখিনি অকল 4 বা 5% হৈছে কনষ্টিটিউয়েন্ট অফ দ্য ইউনিভাৰ্ছ। তাৰ বাহিৰে 23% প্ৰায় what we call dark matter. Dark matter মানে তাৰ ইনফ্লুৱেঞ্চটো আমি ধৰিব পাৰোঁ গ্ৰেভিটি থ্ৰুৱেদি। কাৰণ আজি যদি সূৰ্যটো যদি আমি দেখা নাপালোহেঁতেন, অনুমান কৰক যদি সূৰ্যটো আমি দেখা নাপাওঁ, কিন্তু তথাপিওতো পৃথিৱীখন ঘূৰি থাকিব, নহয় জানো? ঠিক তেনেকৈ আমি তৰকা ৰাজ্যবিলাক চাব পাৰোঁ তৰাবিলাক কেনেকৈ ঘূৰি আছে। আৰু তৰাবিলাক কেনেকৈ ঘূৰি আছে আমি চাবলৈ গ'লে এতিয়া দেখোঁ যে অকল যিটো আমি চকুৰে দেখোঁ তৰা বা ইটো, তাৰ উপৰিও বহুতখিনি মেটাৰ আছে যিটো আমি দেখা নাপাওঁ। দূৰবীণেৰ কোনো ৰিজন অফ ইলেক্ট্ৰমেগনেটিক স্পেক্ট্ৰাম আমি দেখা নাপাওঁ। সেইটো আমি ডাৰ্ক মেটাৰ পাওঁ। আৰু আমাৰ বিশ্ব ব্ৰহ্মাণ্ডত সেই ডাৰ্ক মেটাৰটো about 23% মান হয়, আৰু বাকীখিনি কয় ডাৰ্ক এনাৰ্জি বুলি। চ' দেৰ ইজ এ ফ'ৰ্চ, এটা গতি আছে যিটোৱে ইজ পুছিং দ্য ইউনিভাৰ্ছ এপাৰ্ট, এণ্ড দিছ এনাৰ্জি ইজ কল্ড ডাৰ্ক এনাৰ্জি। কিন্তু আমি সেই ডাৰ্ক এনাৰ্জিটো কনষ্টিটুৱেঞ্চ কি আছে, কেনেকৈ আছে, সেইটো এতিয়াও আমি বুজি পোৱা নাই। গতিটো নাথাকিলেহেঁতেন তেতিয়া যিটো যদি ইউনিভাৰ্ছখন এক্সপেণ্ড নকৰিলেহেঁতেন, সেই স্পেচ টাইমটো একেই থাকিলেহেঁতেন। যদি এখন তৰকা ৰাজ্য ইয়াত আছে তাতে বহি থাকিলে। কিন্তু আমি জানো যে আজি স্পেচ টাইম আইনষ্টাইনৰ ইকুৱেশ্যনবিলাকে সেইটো এটা চলিউশ্যন দিয়ে যে ইউনিভাৰ্ছখন এক্সপেণ্ড কৰিব পাৰে। দেৰ আৰ 3 মেইন কম্পনেণ্টছ অফ দ্য ইউনিভাৰ্ছ। এটা হ'ল বেৰিয়নিক মেটাৰ বুলি যিটো কওঁ, যিটো ইজ মেড আপ অফ অল ডেট উই চি। ওৱান ইজ ডাৰ্ক মেটাৰ, যিটোৰ গ্ৰেভিটি থ্ৰুৱেদি প্ৰভাৱটো আমি ধৰিব পাৰোঁ। আৰু থাৰ্ড হ'ল ডাৰ্ক এনাৰ্জি, যিটো প্ৰভাৱ আমি ইউনিভাৰ্ছৰ আমাৰ বিশ্ব ব্ৰহ্মাণ্ডৰ ম'শ্যনটোৰ ওপৰত আমি ইনফাৰ কৰিব পাৰোঁ। আৰু হোৱাট ইজ ডাৰ্ক এনাৰ্জি সেইটো আমি এতিয়ালৈকে আমি গৱেষণা বহুতে কৰি আছে, কিন্তু হোৱাট এক্সেক্টলি কনচিষ্ট অফ এণ্ড হোৱাট ইজ ইট উই ডোণ্ট ন'। কিন্তু তাৰ প্ৰভাৱটো আমি দেখোঁ। ডাৰ্ক মেটাৰো যদিও কিছুমানে ছাজেশ্যন কৰিছে নিউট্ৰিনো হ'ব পাৰে বা মেছিভ নিউট্ৰিনোজ হ'ব পাৰে, কিন্তু আমি এতিয়ালৈকে সঠিককৈ ক'ব নোৱাৰোঁ যে আমাৰ ডাৰ্ক মেটাৰটো এইটো।
So what is multiverse?
Multiverse. Okay. What is multiverse? Okay, we have our universe, right? Our universe also, it is believed that it originates in a very hot phase of the universe, and it is expanding all the time, and also accelerating in more recent times. Now, if we look at our universe, we can only see till a certain distance, and our universe is estimated to be about 13.8 billion years old, but we cannot see beyond a certain phase of the universe. Because when it was very hot, it was also very dense. And if it is very dense, light itself cannot get out from it. So we cannot see beyond the phase at which light is emitted. Today, people speculate that we may be able to detect gravity waves from the very early phases of the universe. But that has not happened as yet, but that is a possibility. This is one universe which we know of, which we study, which we observe, jita bhi dekha pao, sukure dekha pao, dubine dekha pao. But there could be other universes as well. Our equations do not rule out that there cannot be another universe. But tar praman ami na jano, eko nai. So theoretically, it's possible that there are multiple universes, but observationally, we know nothing about it. Even our own universe, we can only see it a certain distance when light actually could reach us. In fact, the evidence for a very hot phase of the universe, এইটোৰ evidence আছিলে জৰ্জ গ্যামো বুলি এজন বৈজ্ঞানিক আছে। জৰ্জ গ্যামোয়ে তেখেতৰ ষ্টুডেণ্টজনক আলফাৰ ক্যালকুলেট কৰিবলৈ কৈছিলে যে যদি এটা হট ফেজ আছে আৰু আমাৰ বিশ্ব ব্ৰহ্মাণ্ডখন এক্সপেণ্ড কৰি আহিছে তেতিয়াহ'লে যেতিয়া ৰেডিয়েশ্যনটো আহিব পাৰিছিলে সেই ৰেডিয়েশ্যনটো লাহে লাহে ঠাণ্ডা হৈ যাব if the universe expands. এতিয়া বাইচাইকেল পাম্পটো এনেকৈ কৰি থাকিলে গৰম হৈ যায়তো, কিন্তু চাক কৰি থাকিলে অকল তেতিয়া ঠাণ্ডা হৈ যাব। So can we see that cool radiation? আৰু সেই cool radiation to আজি কয় cosmic microwave background radiation. আৰু তাৰ temperature to is only about 2.73 degrees Kelvin. So the thing is that we know our universe, we know a lot about it, and by knowing a lot about it, we also realize how much we don't know about it. ঠিক আছে?
Yes, sir.
So আৰু প্ৰশ্ন আছে নেকি?
Sir, we know that Einstein proved one thing, that nothing can exceed the speed limit of light.
Yeah.
Okay, but recently I read an article and we come to know that the circumference, or what we say, the length of the observable universe is about 93 billion light years.
13.8 billion years. Yeah, 13.8 billion years is the age. You can put light.
But the the vast and the distance is about 93 billion light years. So I want to ask you the thing that if universe started about 13 billion light years, then how it became 93 billion light years?
See, 13.8 billion years is the age of the universe. 13.8 billion years. You can ask how much in 13.8 billion years, how much light can travel. You can do that because velocity, distance is velocity into time, right? So that is a different calculation, right? But the age of the universe, as we estimate it today, from the expansion of the universe, number of ways that this has been done, you can similarly work it backwards and look at when it may have originated. And if you do those calculations with the most sophisticated sort of observations that we have today, from observations of movements of galaxies, dynamics of clusters of galaxies, and also the cosmic microwave background radiation, that we estimate the age of the universe to be 13.8 billion years. Your question about the maximum velocity of light not being exceeded, that is true. That Einstein's special theory of relativity postulates that nothing moves at a velocity greater than the velocity of light in vacuum, which is close to about 3 into 10 to the power of 10 centimeters per second. All right. Now, there were various anomalies which existed to resolve that. He put forward the special theory of relativity, which actually put this limit. Now, there have been claims periodically that they found something which goes faster than the velocity of light. One of them was an experiment from CERN, which they said they found neutrinos actually traveling faster than light between France and Italy. Obviously, it raised some alarm because CERN is a very well-known observatory, but later when it was worked out, it was found that there was some problem or error in the clock. So today there is no experiment which is there which actually proves that anything goes faster than the velocity of light. Now the other thing is that, for example, the problem with Newtonian gravity was followed. It says force is equal to gravitational constant multiplication by mass and inverse square of distance. Newton's laws of gravity implies that the force I have to get a rope to you and pull you back, isn't it? There is a time in which the signal has to travel. But Newton's gravity was instantaneous. So that was a problem with an apparent inconsistency with signals having a maximum velocity of that of light. Current for the Earth to know that the sun is there, or for anybody to know that another body is there to attract it, the signal has to travel. But the fundamental problem with Newton's gravity was that it was instantaneous. So that was again resolved by Einstein's theory of gravity, which says that mass actually affects the structure of space, and other bodies are just following the structure. They're following the minimum path, or what is called a geodesic, in this curved space-time. And if you look today at gravity waves which have been detected, they also travel at the speed of light. Ripples of space-time which were detected recently at the LIGO observatories in the US. Now, if you look at the difference in velocity, they've tried to put limits in difference of velocity of light and gravity waves, and just to check as a check, and those are extremely small. But don't be confused by one thing, which is that there may be apparent velocities which exceed light. Kaile jodi moi eta torchlight long, I mean there are objects like that in space, and I move it about. Kaile jodi, if I look at the speed at which the spot moves from here to there, that will be a certain speed v equal to r omega, right? Now suppose I increase r indefinitely to the furthest regions of space, then obviously your velocity at which the spot is moving will exceed the velocity of light, but you're not transmitting information at it. Okay, so there could be apparent velocities which are greater than that of light. Once you carry torchlight aeroplane, I can video or torchlight usually, if I can see it, say million kilometers away, then obviously the spot will move faster than the velocity of light. But that is not the velocity at which you're transmitting a signal, transmitting information. So information is always limited by the velocity of light. Gravity waves also travel at the velocity of light. And the problem with with Newtonian physics or Newtonian gravity was that the force was instantaneous. That was resolved by Albert Einstein in his general theory of relativity, where he said that matter itself affects the structure of space-time, and matter and other matter follow the geodesics created by this distortion or curvature in space. Yeah? Our प्रश्न आसान है.
Sir, unlike other planets, why Uranus is highly tilted in its axis?
Okay, let me come back to a little bit of formation of planetary systems itself. Right? A little while ago, Maulana Nagote, I was talking about stars forming by the collapse of clouds. Right? Now, when clouds collapse, then invariably there is a certain, things are not absolutely stationary. There is a certain angular momentum associated with it. And as matter collapses, then the angular momentum is conserved. And material which is around it, they tend to form a disk around it. Disk can form because in a perpendicular direction there are no centrifugal forces, so it collapses. In the equatorial axis, it forms a disk. And the planets are formed by condensations in the disk. All right. So the thing is that different lumps which form may have slightly different dynamics. They're largely in a plane, but the tilt and all that will be determined by the local dynamics of that particular region which collapsed to form the planet. Okay, so there could be planets with slightly different tilts or orientations or axes, but overall it will be roughly in a plane, just like our planetary system. All right.
So I have a question, sir.
Okay.
So I've noticed that, so when I light a torch, so to a certain distance I can see it. So, but beyond that I cannot see it. So in this case, sir, does the light travel an undefined distance or it travels a defined distance?
See, today you think of your eye as a telescope, as a detector which is trying to detect a signal. Now, any signal which is emitted, its intensity will decrease with distance. Today, for example, I'll just show you, they're like your eyes detecting radio waves. Now, to detect very faint signals, you need very sensitive detectors. Now, your light will travel, but your intensity as it goes further away is going to decrease as 1 upon r squared. So, beyond the point, your eyes will not be sensitive to it. For example, today, if you look at the night sky, you can see stars till a certain magnitude. But there are billions of stars which are actually fainter than that which your eyes don't detect. And the other thing I should mention is that, for example, since you raised this question, if I hold my two fingers, you can see it, right? But if I went to Pan Bazar and did it, you may not be able to make it out, isn't it? And that is another aspect of your eye, which is the angular resolution. The angular resolution depends on the diameter of the eye and the wavelength at which you're observing. Now, for example, because optical wavelengths are small and your eye is also reasonably small, in fact, if you calculate as lambda by d, you'll find that the resolution of your eye is about an arc minute. Protected to Achille 1 degree, you can make out, you divide that into 60 parts, so 1/68 of that is an arc minute. So your resolution of the eye is of that order. Because the radio waves are big, so we need to make very big antennas to get those kind of resolutions, because the wavelength is large. So for them to have resolutions, today we combine signals from antennas which are as big as, Guwahati-IN or even larger, to actually look at resolutions which, say, if you held a 1 rupee coin in Lal Killa, you should be able to say what the structure is. So two aspects: one is the detection of intensity, the other is the ability to resolve small objects which are critical for any detector, including the human eye. Okay? The moon is about 30 arc minutes or so. So just do these simple sums on the back of an envelope at home and try and sort of get yourself. But intensity you cannot detect, because beyond the point when it falls below your detection threshold. All right?
Thank you, sir.